Hi, I'm Frank Carver, and I've been working in the computer industry for over 25 years now. And during that time, I've gradually become aware that there's a significant problem with the way that computer software is developed. So I stopped working for a while and gone to the University of Suffolk to do a PhD in software development and sustainability. Now, this is a big area, so I think before we get started, I'll give you some background. A lot of people seem to think that the internet and the cloud is in some way free, and that's usually because it doesn't actually cost very much for end users to use. However, there's a lot of cost behind the scenes. Estimates in 2019 reckoned that data centers and the internet produce about as much CO2 as the entire aviation industry. Now, that's a lot. Now, although the aviation industry has decreased in 2020 for all sorts of reasons, the use of the internet and data centers has greatly increased. So at the moment, I would suggest that the data centers are producing far more CO2 than the aviation industry. Now, depending on how you count it, the figures say that somewhere between 1 and 2% of all generated power in this country is used to power data centers. And another 2019 study reckoned that globally around 10% of all generated electricity is used to power the internet. Now, this is a lot, but it gets worse. If you look at the actual use of fuel to go into power stations, what you find is that by the time you actually hit the servers in the data center, about 80% of that has been lost. For every kilowatt that goes into the power plant, you lose 80% of it on the way to the data center. So some of that's in generation losses, some of that's in cooling and lighting, some of that's in distribution, it's lost in cabling, some of that's lost in redundant backup power systems. But the point is you've lost 80% of it, so you're already down to 20%. And even more than that, when you get into the data center and into the server, you lose a load more power because servers have their own power supplies. They have their own spinning fans and spinning disks, and they have bits where they're running and not actually doing any useful processing, but still consuming power. So as a rule of thumb, you can sort of say that about 1% of the software, of the fuel that goes into a power station that's routed out through to a data center actually results in useful software processing. So to turn that around, what that means is if you can save 1 watt in the amount of power consumed by your software, you can probably save something like 100 watts at the power station. And obviously you can multiply that up. And given that there are over 100 million servers on the internet, according to the latest estimates, what this is telling me is that software efficiency really matters. It might not feel like it, but it does. So obviously, if you've been through any kind of computer science education, you will have been exposed to the idea of efficiency. People talk about big O notation and they compare different algorithms and say this one is much more efficient than that other one. But this is all very theoretical, and there are problems with the way that computing is taught at universities. So mostly they start by saying, okay, we'll assume you're starting with a blank page. You're writing your software and you're the only person writing it, and you can use your best principles and practices. And we go through and look at lots of examples. However, there are problems with the way this is presented. As you can see on the slide here, you can't fit an awful lot of software onto a PowerPoint slide, and in general, if your software won't fit onto PowerPoint, it probably doesn't get taught. In the real world, though, nobody works at all like that. In the real world, what happens is you don't start with a blank page. You start with either an existing project or you start with something you need to do, and you immediately go out and you find libraries and modules and pre-packaged components that you can use to build your solution. And on the screen now is a kind of whole load of different places you can get these things from, but they all have the same characteristics in that broadly they are all free, which means that you can't even say, well, you get what you pay for, because they all cost the same. And they all claim that they do whatever the job is. So in order to work out how useful this is, I decided to do some experiments. So in order to work out what I looked at, if you think about a typical web page, okay, you've seen plenty of web pages, and you may not have thought too much about what was on it, but usually there's a combination of some stuff which is the same either every time that web page is fetched or on lots of other web pages, and there are some bits that vary. And so generally, it's been a long time since anybody sat down and actually sort of typed all the HTML stuff to make a web page or a website. Usually these things are generated using what are called templates. So with a template, you have some fixed bits and you have some what are called placeholders that get filled in with the bits that vary. So this is a very common software concept that's used in the web billions of times. these template engines are run in order to generate pages. So what I did was I selected a representative sample of some of these template languages that are used to generate these template pages, and I compared their performance. Now, this shocked me because what I found was that between the best and the worst in my little sample, there was over 1,000 times difference in performance. Now, that's particularly huge because if you think about it, if you were building a web application that you were putting on the web and you happen to choose the one that was least performant out of my set, you could potentially need 1,000 times more servers than you would if you use the other one. You might get away with one server for a given load if you're using the efficient one, or you might need 1,000 servers to serve the same load if you use the less efficient one. And when you add up all the multipliers we've already talked about, this could actually turn into a huge power saving. Now, this is all made very complex because you would normally say, well, okay, as a software developer, well, of course I'd choose the better one. But the trouble is we don't know. So I did a quick search on GitHub, one of the most popular software component sources, and I found over 9,000 hits for template engine. So if you're looking for one, you've got an awful lot of choice. But the documentation for all of these ends up saying the same kinds of things. They all make marketing claims. They say they're fast, they're powerful, they're flexible, they're better than this, they're as good as that. And the poor developer is left with no information about how to determine it. So we need to solve this problem. And really there's two things we need to do to solve this. The first is we need more information. Because if you compare this with other fields, if you buy a home appliance, it comes with energy stickers and certification. If you buy an electronic component, it comes with a complex data sheet which tells you all sorts about what power it consumes under what load. If you buy a car, it comes with miles per gallon figures, and people go into lots of detail arguing about whether that's true or better or worse. But when you get to software, essentially the feeling is, it just about works, we'll use it, move on to the next project. So the other thing, as well as more information, is we also need more education. We need software developers to understand that these kind of decisions matter and that it's worth putting a bit of effort into determining which ones to use and how to have a strategy for choosing the components you use, particularly when they're all the same price. Industry has typically had a purchasing model where you get tenders, you evaluate things, you go for the cheapest price. And all of that has worked for a long time when things did actually differ in price. But in the software world, because things are broadly all the same price, often the purchasing system just shuts down and people say, well, they're all free, use whichever one you like. But as we've seen, they're not free in real terms. So lots of these organisations that are on screen right now have got guidelines for accreditation of training courses and certification courses and degree courses. And all of these have now got sustainability clauses in their guidelines. But the problem with this is it actually takes a very long time from the introduction of some guideline through to actually making any difference in the real world. So the guideline's in, then maybe it'll be another few years before a university decides to revalidate a course and come up with a new one. So they'll create a course. It'll now take another couple of years to go through the process of creating the course. Then you've got several more years while students go through that course before they graduate. Then those students come into the workplace as new people that nobody cares what they say. So it's another few years until they're in any position of responsibility. So realistically, we can't afford to wait a decade from this goodwill about sustainability to actually be used in the workplace. So we've got, as software developers and software engineers, we've got a big problem ahead of us. So in order to attack this, I've got a sort of multifaceted ongoing research. So I'm continuing to evaluate component performance. Obviously, me as an individual or a small team can hardly make a dent in the massive number of components that are out there. So I'm particularly looking for more people who want to get involved in evaluating components and help build a culture of including more information. I'm going to not just measure performance of these, but actually make real power usage measurements of them in situ, running in real applications on real hardware. Because apart from anything else, we need to find a model where we can say, okay, if I make a simple test of, for example, the time it takes on something to do something on a reference platform, then if we've got a model which shows us how we can extrapolate from that into the real power usage in a variety of real situations, then we know what we're looking at. And I also want to get help set up systems so we can publish this documentation and make it more available. So when people are looking for particular components, they will have a source that they can go to for documentation to evaluate them. Now, the other lobe of what I'm doing here is the education side. So I'm analysing the curriculum guidelines from the organisations that I've shown you already, but I'm also looking at actual university courses that are currently being run at real universities. So I'm in discussion with a variety of lecturers and course leaders to try and work through what's being taught and whether there are any shortcuts to actually getting more sustainability information into their students in the stage they are now, to try and get these sustainability aware software developers into the workplace sooner rather than later. And to make that even quicker, I want to get involved and consult with industry so that we can talk to industry partners to get them to talk directly to their staff, and to make everybody more aware, and try and, again, to build a culture of being aware of sustainability and the environmental impact of the decisions that real software developers make on a day-to-day basis, but are not really usually considered. So the call to action, if anything, is if you are any of these people, if you're an academic involved in computer science courses, if you're in industry and want to discuss with me making smarter choices about sustainability in software, if you'd like to collaborate or contribute in any of the aspects that I've talked about already, or if you're just interested in any of this research or of the results I come up with, please get in touch. Okay, you can contact me at University of Suffolk. You can also contact me at University of East Anglia, so that's f.carver@uea.ac.uk, or I've got a blog about all these topics at greenprogrammer.net. Thank you very much.